This video contains sample clips from Solving Inequalities, Part 1. The list continues on and on in this way. Many numbers make this statement a true statement. Draw an open circle around the point that represents the value of star because the value of star is a boundary number, but it is not a number that we want to represent. It helps us describe the numbers that we want to represent, but it is not one of the numbers. Points represent the numbers that are greater than the value of star.
Very nice. We can represent the solution set x is greater than 3 with
the first expression is greater than the second expression, or the first expression is equal to the second expression.
You're right. We can represent the solution set x is greater than or equal to star with this shading on the number line. Good. We can represent the solution set x is less than star with this shading on the number line. We draw an open circle around 5 because 5 is a boundary number. It is not a number that we want to represent. It will help us describe the numbers that we want to represent. Next, we shade the points to the left of 5 because those points represent the numbers that are less than 5. Very nice. If square is less than or equal to star, then square is less than star, or square is equal to star. Answer choice B. You're good. We can represent the solution set x is less than or equal to star with this shading on the number line.
First, we mark the boundary point that represents a -2 on the number line. We fill in the circle around a -2 because -2 is more than a boundary number. It is a number that we want to represent. Next, we shade the points to the left of -2 because those points represent the numbers that are less than -2. If you add an expression to the left-hand side of the inequality statement, you must add the same expression to the other side of the inequality statement in order to still have a true statement. Some examples. If A is less than B, then the addition property of inequality says that we can add C to both sides of the inequality statement. If we add C to the right-hand side of the inequality, we must add C to the left-hand side of the inequality statement.
Correct. If x minus 5 is greater than 2, then A is the next step in the solution process.
We have used our rules to change a more complex inequality into an inequality that talks about x all alone. We add 3 to that side, and our addition property of inequality says that we must add 3 to the other side as well in order to still have a true inequality statement. We draw an open circle around that point because the value 8 is not one of the numbers that we want to represent in this solution set. It is a number, however, that helps us describe the numbers that we want to represent. The numbers that we want to represent are represented by the points to the left of 8 on the number line, and we shade in that direction.
Nicely done. If y plus 3 is less than or equal to 6, then A is the next step in our solution process.
We're going to subtract 3 from that side. And our subtraction property of inequality tells us that we must do the same thing to the right-hand side and subtract 3 off from there as well. We can represent the solution set with shading on the number line. First, we mark the point on the number line that represents the number 2. But we draw an open circle around that point because that value is not one of the numbers that we want to represent. It helps us describe the numbers that we want to represent, but it is not one of the values that we want to represent in the solution set. The values that we want to represent and describe are the numbers greater than 2, and we represent those numbers by shading to the right of this point on our number line. Solving Inequalities, Part 1.